in a frozen wasteland over these last 2 days. We have 40-degree weather today. I'm very cold. I dislike it.
It's even colder than here also.
Yeah.
We're going to be back in the 80s, though, tomorrow, I
We're not back to the 80 until July.
hear.
It is warm here.
Good morning, everyone. Link, enter privileges, and here we go. Update the doc too. Let's give like 5 minutes till 9:05 for more folks to join. Meanwhile, I have a talk that I present today in today's meeting to get feedbacks on. What this talk captures is essentially the types of predefined masks and the data types, which makes more sense from the data types perspective. So we can go from there.
So, sorry, I'm reading over it right now. Mask to default. This is already defined by the mask. Is that what you're saying? Like the default is a mask specific?
Yes, it's data type specific. So essentially what you're saying is that for each data type, this is the default value that will be filled.
But it's not customized, right? It's just, if a user uses this, it's what we define it as right now.
Exactly.
Okay.
Yeah.
I think that's where it's confusing.
Yeah. Sorry. Let me see if I can better the text now. Let me screen share as well. Oh.
And BigQuery supports that?
Yes.
And this is just for like engines that need it to be the right type for some reason?
Yes, and the columns which cannot be null. So one of the things is that if you see the values can be used to guess. Like for example, if I were to convert yes to a mask alphanumeric value, I would have been able to guess that it's yes or no based on the column name description. Rather than that, you just like pad everything and make everything XXX. So that is one of the goals to achieve. And obviously you can't nullify them because that's a required column. It's not an optional value. So those are the cases which I had in mind.
So why not? I'm wondering if you would just combine this with replace with null.
Interesting. Some places, that's interesting.
Because like, why would I want to expose that there is a value set? If so, like in the case where the field is optional, if I do mask to default, I will let users know that a value is set or isn't set because some will be null, and some won't.
Yeah, some would be filled with pads with XXX. That's interesting that if the value is not set and it's an optional field, what would mask to default go with? I think that would go with null still.
Yeah, it just makes me think maybe the two of them are actually combinable. Just be like, this is, if it's an optional type, you get a value that means nothing. And if it's a nullable type, you get null for everything. I'm trying to wonder if there's like it's basically masked to default, but for optional anything, the answer is null.
I see. That could be a way to combine the mask actually. But then this mask has to not be called mask default or mask null, or it should be like mask fill, something of that sort, and then define that optional field will be nullified and required field will be converted, like filled with the values that you want to.
Yeah, I mean, they say they have anonymizer is what Postgres calls it.
Yeah, that's an extension that Postgres has called PG Anonymizer here. Yeah, but it's not natively, like at least when I was searching, I didn't find anything very native to Postgres on this one. But they have a anonymizer, they have a way to add noise, they have a way to add like random things in between.
So again, for both of those though, why do I even want them? Why am I showing the user that this column exists?
Like this column exist is a different problem. Like column hiding can be this could be a metadata operation. Like, should I support column hiding or not? Maybe one could directly delete that column or remove that column from the schema itself to give an impression to the readers that it does not exist. But this is for mostly data masking, that okay, this column exists, and now given that this column exists, you can't see the value. Maybe that's one way to portray this.
This could be data analytics related things, right? How many, let's say that you have a form and you are just filling the table on the back, then basically you will learn that how many of them is field values, which you are not allowed to see the values.
But is that insight that much useful?
Say it again.
Sorry, Russell was saying something I can go after. Okay, my question is that, is it a valuable insight to get from the data, given that like whatever inference you're making, like, okay, filled, not filled, is this a valuable insight to get from the data from analytics point of view?
I don't know, though I can check that on the BigQuery side. What was the customer driven? As a data analytics, I definitely see the value. Like, if it is gender column, for example, if you don't fill the genders, then that those users doesn't want to disclose their gender. This is one information, right? Then without knowing their gender, you just want to know, do they want to disclose or not? If null, which means they don't want to disclose it.
But people have options of NA also, right? Then you need to, as a consumer of your data, you need to know how your data is inside your table or like in your source organized. Because what if there is no null as an option, but there is NA as an option, right? Or maybe some other option.
If I agree, if you planted that column, from initial time, yes, you are right. There could be another use case, like you added that column later on, right? The previous values are null and the new values are already filled. And you may want to know that also too. If you tell me which masking on the BigQuery, I can try to check the product definition for that.
Replace with null and mask to default is the special things that we are thinking of and handling, that can we combine them into one shot.
Okay. I think Talat's making the argument for mask to default, and I kind of get that. So basically, it's an is set. So like if we don't break if it is set, but we don't give you any useful information there either.
Does that mean that you can join on it?
I guess you could get all the ones that are null. That's about it.
So does join happen before or after redaction?
I think it should happen after redaction, right?
It happens after.
Yeah.
Yeah.
That's what we wrote in the rules, right?
Yeah.
You apply masks and then return.
Yeah, we first apply the filters without the unmasked values. So filters see always the unmasked value and operate on unmasked value of that column. Then you apply the mask and only then you read the values from the table. That's the rule that we have written in the order of execution.
Ooh, okay. Is that consistent? Do we have something that we're basing that off of? Just because then you can do point attack against values.
I mean, you mean like predicatory orders, or like you can say or pass something in your filter that can
Have
row filter?
something very specific in my filter, and that would expose what the value is. So
Precisely.
like the gender question, I can say, hey, well, this name, and was it female?
Yeah.
So that's kind of like an interrogation attack, right? So,
Yes. Totally agree. So we raised a thread in Iceberg dev for this to know exactly what does Trino do in this scenario. Trino's guarantee is that if they have a predicate, that can lead to like, divide by zero kind of an attack where you expose the data by running those things in your data. They take the responsibility of not pushing that down or executing that in a secure, like they take the responsibility of not letting that happen. And if that happens, not letting them show to the user what happened with the error messages. So this is what, like, even in Snowflake, we have a secure view. And if you are defining that kind of a, filter that can be pushed down in your execution. So there are, okay, let me take a step back and explain. There are two types of things. Number one is that, okay, that kind of a thing is inside your policy, right? Which is now being evaluated as part of your row filtering. Then that is, as an admin, the fault of the admin to do that. The second thing is your data filters now getting pushed down along with your policy filters or authorization predicate and then getting executed in the same way. To which that the stance is that, okay, if those filters get pushed down and get evaluated before the masking has been applied, then it's the responsibility of the engine on why did it allow to them to get pushed down and get evaluated with your authorization predicates. So in both this, in first scenario, it's the admin's fault on writing such kind of a policy, and I'm not sure any conscious person will write that. Second thing is someone is writing a data filter which gets pushed down to the execution with the row filter, then it's the problem of the engine, and the engine takes the responsibility in that case. Maybe I should post that thread. Does it answer your question?
well, I mean, it answers my question about the discussion. I'm not sure it answers the underlying problem, though. Like, I can see being able to apply filters to non-masked columns, but why would we allow filtering of masked columns?
I'm a little confused on the question here. So like, how would you be able to interrogate if you only have the masked value?
Well, but you said that we apply the filter first, and then
Oh, no, other way. Mask first.
Oh, okay.
Sorry.
That changes everything. No, I thought you said that it was filter first, mask, then join.
Oh, sorry. No, I said it the opposite then. The spec says you must mask, then row filters, and then then it's the engines after that. All that stuff has to happen first.
Okay.
Which filter are we talking about?
Yeah, that's the question, because like the row filter are
Yeah.
basically against the row filter provided as like access control are basically on the unmasked data.
Yeah.
But like if people are adding their own filters,
Yeah.
then they apply on top of a masked data.
Okay.
Yes.
Okay. So it's actually row filter mask
Yes.
first,
Yes.
then user filters.
Yes.
Okay.
So
Okay.
this is the exact, so the query filters, let's put it in authorization filters or row access policy filters. And then there is like query filters. Query filters push down is entirely engine's responsibility if they are executing it with the authorization filters. And if something gets exposed into that, then it's engine responsibility. So that's what happens. Now I can execute them after the masking has been applied, or I can execute them together with my row filters if they get pushed. It's like the engine so proprietary. But from the spec perspective, authorization predicates are executed before the column projection column masking has been applied. Okay. Okay. Sorry, I think I waited this for bigger time. Maybe then let's get into the mask. What do you think? Let's just like go through each of the mask and then for the data types that I have collected on this and see where we go from there. Okay. So the first mask is mask alphanumeric. This is essentially, you want to preserve what is there inside your string text, and you just want to redact parts of the things, like, replace the integers with n. You want to keep the punctuation, so something is like 1,3 zeros, so it remains like 1000. Similarly, for every other Unicode character, it's X when we leave the punctuations as it is, and all other like characters or the special characters as it is. So here I've just taken example. I've not mentioned @, but it would be something like this, for example here, and you can use it to just keep the posture that okay, it's like what exactly it contains. Like 1000 will be n comma n 4 times. So this is one of the masks that we got. This still gives some inferences from your value inside the mask. And then while researching, we just thought that okay, string is something that we want. Then the second is replace with null. Essentially, this is if your column is an optional column, then replace the value with null. But obviously, the other case is like, if it's a non-nullable column, how do you replace it with that? So everything that can be having a nullable value, that is a target to this, and we can think of that as a data type that it is applicable to as a mask. Then you have
follow the Russell's point earlier. If they just replace it with the default could be null, default could be some default value. Would that combine the two cases well?
I didn't get you. Like default will be null only for a nullable column.
Yeah. So because I'm trying to you mentioned for nullable column, for required column, what do we do with that?
It is must to default, right?
Yes.
Yeah, master default is predefined. So
Yes, for each data type.
So again, just kind of follow Russell. Can those two combine together just a mask to default? Would that be one thing? Be have both?
yeah, because if it's like, so I think the question is back to, do you want to expose whether values are set or not? So I think Russell said that it's kind of like the difference between them is set. I think it's reasonable to say that you can't use replace with null on a non-nullable column and just say, well, you have to use mask to default. Like you're not getting any additional information, right? And since there are no null values, like it's either all the default value or in mask to null, it's all null value. So there's no additional context or meaning by having all null or all default.
Yeah, the null one is still getting me because I'm wondering like why do we want to return a column full of nulls as opposed to just not expose that column?
I think it's a workaround when like you cannot like basically block access, or you don't want like people like to have like, you don't have like select star except those columns, and instead say you know what, like I still allow you to do select star, I will just never return you any data.
Yeah, but I'm just saying we can already do that, right? We can just say like,
Well,
you aren't allowed to load that column.
Well, so the one difference that you can do with mask to default is you can select where not null.
Oh yeah, that one I'm on. I'm bored.
Okay, so it's
bored with that. I'm
with null.
replaced with null. Yeah, like
So
what's the difference between us just saying you can't select this column and we give that back in the set of selectable columns, just don't include it?
Russell, I actually asked some users this question, and the answer was that you can preserve the data shape of the table, which is actually pretty useful for some folks. Like if you prefer to actually see that the column exists and use that column information for data frame operations.
and it's like Tableau, right? If you use the Tableau or Locker to query someone just write and build the dashboard, you may not have the data columns to see that, but you don't want to change the schema of the table or the dashboard.
Or actually, like, since we're talking about data shapes, like the semantic layer, let's say you are building views on top of, but like really like what you want is really like control who has access to some columns or not. Like if you need to define your view based on like, oh, this column is present, it's not present, that can be hard to manage.
So we currently do return the whole schema though, right? Like we return the whole schema of the table regardless of what isn't there. Are we saying that like the engine then should propagate that all the way through, but just hide the columns.
So my understanding and take of this is like column hiding can be done purely from the schema point of view, because there are like policy stores like Lake Formation and like Microsoft's OneLake, which just supports column hiding, and they can be supported by just hiding it over the schema and making sure that the engine, for that engine, that is the only schema that they see. Historically, from all the schemas, they just remove that particular column existence. The question is that, given that we know we want to preserve the schema and don't want to change anything on the schema, what our answer should be to redact the values of that particular column in the schema, because column hiding can be achieved by schema itself, given that we do such kind of things. But it has certain challenges. If you see like the metadata tables, like for example, people have information schema as a separate table than that of the actual table when you do the describe. People don't authorize against that in showing that, okay, this particular column does not exist. So that's why they call it data masking, and they call it column hiding as a difference. So I'm just like thinking that, okay, if we want to do column hiding, we have different ways to achieve it. Maybe there can be an action which suppresses that particular column. But given that we want to keep the column, what is the appropriate mask for that particular scenario would be is a question. Now, whether we should mix it with the mask to default, whether we should have just one mask called mask to default and have null being filled as an optional value, so as a value when the field is optional, that could be an extension to the mask to default, is what I think. What are your thoughts? I mean, I believe that these are like this is an assumption based on that, okay, we want to have the schema intact so that the underlying reader or the consumer of this particular data does not have to deal with the column being not being able to see that.
I think those two are like fair points. But I do think it's maybe helpful to decouple the question of like, what is the user trying to do as a policy intent? Like, what are they trying to achieve with this data, from the nuances and complications that come from the implementation of that on the client side? Like, of course, those are challenges, and we should acknowledge them, and we should think about them when we decide which of these we're prioritizing to implement first. But I do think, going back to the original point, based on what I heard from the user, and it's really interesting because I had the exact same confusion as well, whether replacing with nulls would be exactly the same on the user side as hiding the columns. But from their perspective, it is different because it is about preserving the data shape when you replace things with nulls. And I think based on that, those two are just two completely separate policy intents. One is to hide the columns, one is to replace with nulls while preserving the schema. And I think it's good to acknowledge that.
So one of the things to look at is we have these reference implementations. And it looks like we've got multiple for replace with null. I'm actually kind of surprised that there's just one for mask to default.
So there is one interesting aspect that came up. The thing is that people support dynamic UDFs in there. And what if you'll see, I mean, I got a chance to look into some of what we see. It's very achievable when people write the policy. They say that, okay, case when then this value is this, otherwise
Okay.
replace it with XXX. That's why it's not showing up, because only BigQuery supports predefined mask. Things like Snowflake, Databricks, Dremio does not support. Does not support like I think predefined mask. Understanding. So that's why it's not showing up in this mask default value. But if you see in the close to the policy content of what they are doing, this is what they are actually doing. If you take up the big policy.
I just want to give one input for the default mask. I was just looking to other things, but I saw that there's a customer asked directly. They complain about the custom UTF because looks like on their use case it is not efficient enough, and they asked the BigQuery team to have a master default to be optimized, at scale.
So one question though, then, is it because that UDFs are also treated as black boxes in BigQuery rather than flattened SQL things that are optimized in line, or are they different? Because like for Spark, it earlier used to treat like UDFs as black boxes. They don't participate in optimization until SQL UDF games.
I don't know, though. I was just looking to tickets, why they created replace with the null.
It may be because BigQuery is like using like UDF stored in as Lambda, and so you still need to scale and figure stuff. So like I know Genio, for example, like we use like SQL UDFs, and so those ones are directly optimized in the planner. So maybe just like a difference of technologies, like of each UDFs are implemented and figure stuff. Yeah.
Agree. And then I think one of the things would be like sandboxing is what you call like inside the SQL content, every UDF is by default sandbox to be executed before you get the result. Maybe that could also be doing that, because it's hard to open up and then expect that, okay, this is not be a thing that does not require sandbox. By default, every UDF would be directed to a sandbox. Just to aid the points on this one, maybe.
This is also important, right? For BigQuery, what I understood that they are doing the sandboxing because to save off the data and the engine itself. This is also same thing for our trusted engine approach, right? Then we should also consider that.
Makes sense. Okay, so just to conclude on the discussion between these two masks, I think the next step is to just see if we can have a one mask to incorporate everything with some optional param. Maybe replace with null when the field is optional can be something that can be a property of this mask. We'll think about this more. Though one aspect is that can, okay.
I thought we were trying to avoid configuration and tweaking with the simple set. Like, I mean, you can always do all those things with a UDF based. So, which is why, we have show first 4, show last 4 instead of show n, leading, trailing kind of thing.
That's a fair point, actually. I think then I think considering what these masks mean in a very defined way, having two masks does make sense rather than combining them into one. Russell, what do you think considering this point?
No, I think it's fine to have both, especially because I can think it's much easier to optimize replace with null than it is to optimize mass to default. Because I can just make a constant vector with replace with null, but mass to default means I actually have to read the rows.
Yeah, most thing about default, we can have the initial default to be null and right default to be non-null.
But the mass to default is a constant function. We should rename it to something like isSet or something, or because we're not actually giving a user choice over what that value is. We're just saying there will be a value of the correct type if there is a value in this column, and there's no other information.
I don't hate the name. Like, it's actually, we're probably just reading it wrong. Mass to default is like we define to the default, right? So we're for every type we're defining. Yeah. So mask to static, mask to,
constant.
Constant. Yeah, that's not a bad one.
I'll take that.
We can smith the name a little bit, but I do think it's distinctly different from replace with null, and I do think potentially like it helps solve the question of like, well, if I have a table that has a required field and I want to do something like replace to null, like we can actually say, no, that's not allowed, because then you can't do create tables select and get the same schema or something like that out the other side. There may be some artifacts of nullability with the replace to null.
Agree. I mean, even in the mask attachment itself at this point, when you attach a policy to Snowflake that is a nullable column, and you try to produce null or return null in the posture, if we see that kind of a thing that you're trying to return null for a required column, we fail the attachment of the policy definition.
Yeah. It probably messes with join operations and all sorts of other things if you start just producing nulls where the engine doesn't expect. Yeah.
Precisely. Cool.
I'm not sure that we need to define that though, right? Like we could go through and we could say like, hey, engines, you do this or that, but that's kind of an engine thing. Like I could easily see an engine saying that, hey, we'll just put a projection on top of your table schema that has a nullable column, and then run all of our optimizations on that, and we can circumvent it. So I'm not convinced that we need to tell engines how they need to behave here.
Yes,
But we could add notes.
Yeah, precisely. This is anyways during the policy attachment. We are not defining the attachment and policy definition. We're just defining that, okay, once it has been accepted by a catalog, how it's giving it back. So totally agree on that point on not being opinionated on what engines should do in case someone wants to attach this particular mask to a column. So makes sense. Okay, so I'll keep these two in. Okay. Okay, I'll move to the next mask. I see there is one question on mask alphanumeric. Lauren, do you want to go elaborate on mask alphanumeric? Otherwise, I would like to cover show first and show last for in one shot.
I think my comment was more general, like for description. Do we? For punctuations, yes. I mean, like if you do like if you give a spec, like you should really give like all the codes.
Okay.
Like just a punctuation, because like actually from Unicode point of view, like it's either like we give like a range or something, but like a concept of punctuation is loosely defined.
Okay, no, sure. I can tighten it up, find the characters, and
I think I have a second comment about like, yeah, we should also add like the nullability behavior for each description.
Okay, sure. Point well taken. I'll trim it and then say that, okay, this is the only list that qualifies as a punctuation, and then while updating the spec, I'll make it handled. Okay. Anything more on this front? I think we discussed this. Okay, I'll then just like go to the next. Okay. Okay. Now is the show for first four and last four. Okay. This is just like, what would you do in these two kind of masks? There is one point that I want to discuss is that values which have less than 4 characters. So there is a text in BigQuery which says that, okay, if they're less than 4 characters, you hash it. Now, the thing is that if you see only because there are 4 characters, you can create a reverse map table and then find out what the value is by just playing around with it. So we just said that, okay, if there are 4 characters, we'll just replace it with follow whatever we do. We will not hash or do anything special if they are less than 4 characters. If for anything in the show first 4, anything after the first 4 is replaced by using the mask alphanumeric rules. Anything in the show last 4 except the last 4 will be masked by alphanumeric rules. And last 4, if the values are not there, we'll just leave it as it is. Now it's your like fault to use this mask. So there was one debate that we were debating a lot on is that, do us as a mask own the responsibility of doing some intelligence in case there is some value that can be predicted by the output of the mask, or is it a responsibility of admin to have or choose an appropriate mask for that particular data in the first place? And I think life is much simpler if we go into an assumption that we have dumber mask which just do what they are supposed to, and a smarter admin who attaches the mask to this particular column, rather than going the other way around. So that's what we are proposing in this one. Any thoughts on this?
I have one concern, if it say show last 4 or show first 4, if I don't have, the 4 characters, then the return shape will be different, right? That's why I don't know why they hash that the values on the BigQuery, but if we can return always 4 characters, maybe this will be useful. I don't know, just
yeah. Maybe then appropriate mask to use is mask to default in case you have such kind of a value, rather than using show first and last 4. You can always pad the things to a given size, irrespective of what the length of that particular column is. If you have a column which has only 3 or less than 4 characters, like for example, the case that we were debating a lot is that this is admin, yes or no, right? It's a 3-character thing, and then another is a 2-character thing. If you just replace it with mask alphanumeric, you will have XXX or you have XX. What you can do instead is that you can have a mask to default, which has a 9 number of X. Now you figure out what is yes or no. Right? So then that's the problem. That's the suggestion. That's the assumption we are going with, that you have a smarter admin and a dumber mask. Yes, Steven?
So what's the concern with padding? I thought we can just pad it with the star. There's no sensitivity information leaked. So just pad it to 4 would be fine too, right?
Yeah, but then
You just use 3 characters. You let's say the show last 4, just show the 3 one. It's also fine because there's no sensitive information on whether it's 3 or more than 4.
So this is where I'm saying that do we want to define these handlings that, okay, first of all, you need to pad it to return at least 4 and then pad it with star, star, star. Do we need to define that in your mask, or do you want to offload this kind of a responsibility to admin that, hey, if you know that your column has less than 4 values, less than 4 characters, why did you choose the mask in this first place? If that is the particular mask that you wanted to do, better than that, you can do mask to default, where you will get everything padded to 9 characters, and that's all that you need to care about.
Mask
That is it. Yeah.
go ahead.
That is something that the matter of debate is. Yeah.
Do you know the differences on the other system like Ranger, how they are handling, or the SQL, how the PostgreSQL is handled for the less than 4?
I can take a deeper look, but I think they fail in this scenario, if I'm not mistaken. Let me take a double look on this one.
That wouldn't be great, because then a new value could break reading the table, right?
Yeah, that's true. They do partial of 0004. No one explicitly defines that though. Okay, actually, let me give a chance on the Ranger. They don't define specifically on this particular value. Maybe then I would see the engine integration on this one. If it's a substring of getting 4 characters, then it will fail. So I remember checking that no one explicitly mentions this particular case except the BigQuery. But I can take a deeper look into what is in the Ranger Trino integration of this particular mask that gives us the value. I can take that action item and come back.
And what does BigQuery do? It pads? Is that right?
No, they just hash the 4 characters, do a short 256 of this.
Oh.
Yes, that's where Ryan was saying that, okay, if you have less than 4 characters and if you are doing the short 256 of this, you can easily prepare a reverse hash of what these values are. So what are you saving by doing those things? Because there are only 4 characters. So
yeah.
That is the main thing. We don't want to do anything special for those 4 characters by applying short of 56 on this.
Maybe just the not changing the shape of the data.
I mean, you're just anyways returning the value that you have on the 4 here, right?
No, you do the SHA for SHA, right? Then you will get just on the first 4 or last 4 of the SHA. Your columns
I'm a
will
little
always
confused.
have.
But why
4
is that better?
characters.
Like if I have a 5-character string, I've got 1 character that's masked, and I have 4 that I know. Why would I suddenly have a more secure thing if I have 4 characters? Because like with 4 characters and 1 unknown, I can get that, right? Easy. If you give me 4 characters straight up, it's only slightly easier. Like from a computational standpoint, that's just as easy for me to crack.
Yes.
So why special case it? I don't know. That's would be my argument.
Well, but it's not hashing in that case, right? I mean, yeah, you could. So if you have a star, you don't know what the value is at all.
I was saying if it's a 5-character string, though, I know what it is because
Well, it's a
I only have
5-character,
one
you get-
unknown.
You get 4 values and you get 1 unknown. So it could be for the hash, you get the exact, like you could go back to the exact value.
I'm just saying, like, if I was doing an attack on this, getting 4 characters with 1 unknown is basically the same.
I don't see how you can get the unknown because it's unknown. It's like, especially if there are duplicates of the 4 values, like you don't know which one it would be with certainty.
So my thought here is like, say this is like a pin code or something.
Yeah.
If I do a pin code and you give me 4 characters, I can guess. I got it. Now, if I have less than 4 characters and you give me a hash of something, then I can't get it.
Yeah, I mean,
It's a weird.
I think that's different though, because like here, it's not like a pin code, right? It's a value, like a zip code, for example, is a good one for a 5-character. Where yeah, you may have the same zip code as a 3, a 5, a 7, but I don't necessarily have the ability to go test those.
Probably could with zip codes.
Yeah, depending on what other information you have, maybe. Like, hey, if you have a street name or if you have something to correlate with it, you might be able to narrow it down. But inherently, just in the value itself, you don't actually have enough information. Whereas with the hash, you know the exact value. Like, you could get back to the exact value.
I mean, I understand that argument. I just, so like, this is a story from my history, but when I was in bioinformatics, we once did this study where you can, like, de-anonymize people using the randomest stuff. And if you have just like 4 characters of a zip code, super easy because you can just use all this other junk about them and comb the internet and get it very easily, get who they are. So it's one of those things where I feel like, I don't know if it's worth the effort to make it extra secure for those 4 characters.
Yeah, I mean, again, to the admin question, like we have to assume that they're acting in the best interest based on their understanding of the data, because it's like how much better is that than just like forgetting to apply a mask to the column, right? Either way, you have a dumb admin because like they chose something that doesn't really redact the data versus they just didn't redact the data.
Yeah.
So we can only do so much to protect people from themselves or their admins.
And also those kind of cases most probably, the back in over time, then people use cases kind of things, maybe we are not able to guess those things. Like initially I start thinking that if it's social security number, you don't want to show that on the call center members, but they always calling when we call them, they always ask the last 4 or first 4.
I agree with this. It's just like, it's the same debate with the email mask that we were having, that okay, do we need this? Do we need 4? But because the thing is that sometimes people ask last 4 of SSN for some authentication as well. So maybe that makes a case for this particular scenario for having a mask. But yeah, I mean, if that's applied for anything except than SSN, then I don't think it's in the best interest of using this mask against that particular data.
If I can rant on the SSN one, if everyone only asks for the last 4, then masking to the last 4 is pointless as a security measure, because you can just use the last 4 with any other service that only needs the last 4. Just a comment there. We do a lot of weird masking things that I don't know are like super useful.
But I can do that, for any BigQuery supported things, I can look at internal, the customer ask. If there is, then I can update for the next meeting. Is there any valid use case, or just someone just come up with like, that this is useful?
You mean this mask itself, or are you saying the case where it has less than 4 characters?
I will look at less than 4 characters because I also wonder that what was the reason. But I'm going to look at replace it now, master default also too. But just tell me, Prashant, if you need any additional, that I can look at also too.
To be honest, I would really appreciate, because most of these masks, if you see, have a common intersection with the BigQuery, so it will be really nice if you can, provide us inputs, what do you think from BigQuery point of things. What I did, at least preparing in this list, is look into some of our policies that people use, including because we have dynamic masking policies. I came up with this mask which makes more sense against the patterns. Some does not make sense, honestly, but we need to support it because we need to be inclusive on those one. So this is from also Snowflake point of view. So yeah.
Okay, sure. Then
Really
we
appreciate
can look at that, all of the ones and try to figure out what was the reason on the BigQuery side.
Okay. Cool. Cool. Sure then. I think then is there any more additions? Obviously taking Russell's point on there can be still some inferences and these are mostly from the point where you have last 4 characters well-defined into a well-defined formatted column value, and admin is smart enough to use this mask against this particular column, which he knows that has a formatted data. Does these 2 masks make sense? With an exception of not doing anything on the less than 4 characters. What do you all think on this one? Or obviously, the action item on me is to research on the Ranger Trino plugin and the Ranger Spark plugin to see what is the behavior on less than 4. So that is an action item on me.
I would love to hear more rationales from the BigQuery side. I was just looking up some, and the Oracle behavior makes the most sense to me. They only let you use this at a fixed length column. So it's a moot point.
Interesting. So do they give any recommendation on the length, or is it length can be free flow?
1 second. I'm still looking at other ones now.
I have not looked at Oracle. That's a good point.
I think the problem with the Iceberg, the string type is variable length. We don't have fixed length string. So that's yeah.
For variable length, they recommend you use a regex.
Regex. Then it goes category of UDS. I don't think we can define regex, right? Interesting.
And then this is I'm putting these in the chat. This is the link for variable ones.
Yeah, I feel it's fine to leave this responsibility to the admin. Hey, it's a string type, it's a variable length in Iceberg, but in practice, it probably will be a fixed length. For example, 3-second number is a fixed length, and just leave that response to the admin. Might be okay.
Just update for email masking and last 4 characters. Both of them is added in 2022. I will just digging more, why it's happening.
Wow, it supports into number data types too. I don't understand how. Because if you redact a number data type, then it becomes a string. And type promotion would be difficult in this particular thing.
I wonder if it's like our truncate instead.
Oh,
just fill in zeros.
Interesting. I haven't taken a look into Oracle one, so let me take an action item to look into deeper into this one as well. So maybe then the action item on this one is to hear more from BigQuery on less than 4 characters, research the behavior of Apache Ranger on these less than 4 characters to define if you need padding or not, but and also check Oracle. And the last one is okay, what do we want to take this revisit again in the meeting to see where do we stand after knowing all these data points? Sounds good.
Those 2 rules make sense. Just some detail we can figure out. Yeah.
Okay. Sounds good. Okay. Then truncate to here. Wait, this one has a comment. Oh, this is in the later part of the mask. I'll cover it later. Okay, so truncate to year, truncate to months. This seems to be pretty standard in a sense that, okay, if you have a date, okay, it's a fixed data type, all you need to do in truncate to year is to truncate the date, month, and the day to be the earliest of the month. And there is not much ambiguity here in the sense that, okay, it's always 0101. Similarly, truncate to month is like, okay, you preserve till month, you just change the date to 01. And it applies to all the data types on this one. And then these are the things that support the truncate to month. This way, the output type, input type is a date and output type is also a valid date that preserves. Remember, we were discussing about truncate as a transform and on date types, and this discussion happened. So this way you hold the posture of, the input and the output type is same. You get a meaningful date and the reduction happens in place. Thoughts on this one? I'll take no, because this seems to be undisputed. Okay, so I'll consider these two as included in the list. Now, this is very interesting. Okay, SHA-256 stable, SHA-256 random hash. I mean, obviously we have naming suggestion and we are all taking new names for vote. So whatever the best name happens, we will change this into those things. But the idea of this is to have like a global masking function that is consistent across engines. And then have a masking function that is only consistent within the context of query execution. Now, the data types, I did a lot of research on seeing, okay, what data types make sense, because the thing is that the output of SHA-256 is a 64 character hex string, lowercase hex string. And if you feed, if you put a string data type inside that function, what you get outside should also be the same data type if you think of. Now, how do you extract the long? How do you extract the int out of the SHA-256 output is something I took a deeper stab into here. Again, converting into binary, little Indian and big Indian part of the things, and making sure that you have a consistent way defined how do you get the desired output type given that you have an input type. So essentially, you convert the input into bytes. Then from the input bytes, you apply the SHA-256 on the bytes. Whatever the output you get the extracted output types on this. So these are the data types to data types. Basically, input to output is same because our first predicate of the rule is that. And then these are the ways to infer the output type given that this is the input type in a consistent way. So I also would like to, before we go into this, I would like to show a sample query that was here. If you see it, like even if you want from string to integer or to number, this can be this much of a complex SQL UDF inside it. So we are just trying to simplify it. Okay, Laurent?
Should we include also like binary and fixed? Since they're just byte arrays.
That's fair. We can technically do that. But one question then, though, is that do you see or have any patterns in which those are actually short? Like, I don't have that much of a data saying that, okay, this is being used in varchar and, sorry, in binary and fixed length. Because this makes sense.
I mean, we do have like patterns in Dremio when people are like binary data and then they convert it back to some like over implementation. I don't know, like if they're applying access control on those columns though.
Exactly.
It's just because for me it seems natural, like from the type point of view, to do a SHA on those on data. So like that's why I'm mentioning that.
That totally agree. It has also a practical touch on it when we came up with this list. So if you have data and if you suggest that, I think binary and fixed length is something that actually fits very naturally because it operates on bytes, output is bytes. So the fixed length, and I think fixed length might be a little bit tricky of, let's say, fixed length 64 to the output fixed length, but we can think about fixed length on that sense.
But I guess you're kind of doing it on the int and all already, right? So
Yes. So fixed length and binary, if you have data points on if they are actually being used for applying access control on that, then I think happy to include that. I didn't personally find that as a data point, but if that's a data point that exists, and request to Talat as well, if you see this in BigQuery, and please let us know. Happy to include that. But currently, the list of 3 things that we have is inspired by the list I could see from the practical point of view, seeing into what we have also in data. String was very logical. Int and long were something that came up, and then obviously because we need to have a consistent way. So I've defined a rule on how do you get an int for an int. How do you pass that to the SHA-256 function? How do you get an int from an int? Any questions on this one? Except like obviously request Laurent and Talat, both of you, in case you want to have a binary and fixed length type included in this, please give us some data points on that. Okay.
You want to get the data point for the binary
And fixed length, yeah, if they're being used in the access control. Yeah. But yeah, okay. So these are the rules. Now, SHA-256 is a random sort. Like this is for the query session 1. So this is something that we need to have like a deeper discussion on, that who gives the salt back, right? I mean, obviously, once we have the salt, we can concatenate. Okay. Yeah, go ahead, Sam.
So I was thinking about this, and I think there's 2 separate policy intents that are maybe being talked about together.
Mm-hmm.
One is around like having a query local secret, right?
Mm-hmm.
So that joins can be done across columns within that specific query. And my thought is that the engine can actually generate that. It can take on the responsibility of like generating a cryptographically secure secret on its side and then apply it. That would actually make this contract a lot simpler, because we would just ask the engine, hey, can you do this query local thing and apply it on your side? The other one I think we discussed, which has a lot more complexity, right? Which is about maintaining a stable global state for a specific column that we want to join across tables, maybe across query sessions, right? And that actually requires the secret to be defined by the Iceberg REST catalog server, and for it to consistently send the same one for anything that needs to be joined across columns, like across tables and so forth. So I think it's good to categorize those 2 separately, because I think the intent is different and the implementations are different.
But they aren't
global stable, can we just say hard coded to a seed 0? Then that can achieve the global stabilization.
Then you open up to yourself to attacks, right?
No, for the global stable, is that?
Yeah. No, but
I think the goal would be that you want something to be cryptographically secure, right? The goal is to anonymize the data. It's like where you have PII data and you want to anonymize it as much as possible, but for some reason you also want to preserve some kind of consistent hash, either within a single query session, right? So that you can join semantically same data across tables within that SQL, or you want to be able to do it across query sessions or tables. And I think those 2 are 2 completely different questions.
yes. Don't you think then that's why we have like SHA-256 table and a random sort?
But that is not secure though, right? The SHA-256 table is open to attacks, attack vectors much more so than having a secret that is provided by and maintained by the Iceberg REST catalog server. So the other aspect is, are you saying that, okay, even SHA-256 random sort can be divided into 2 things, like SHA-256, let's say very local and global state. Yeah, global. Okay, but SHA-256 as a stable, or like just applying the raw SHA-256 is another way to achieve global thing, but you want another vanilla of SHA-256 global where REST takes the responsibility of SHA-256 stable. I don't think is secure enough for that purpose. It's very much susceptible to attacks. Okay. So it shouldn't be advertised as something that should be used over PIIs.
I mean, everything is susceptible to attacks. I mean, like the question is what's the intent? Like the attack is like if you are doing two different queries and you get the same, basically same value, you can infer that like, oh, potentially like that's the same original value. That's the type of attack you're having. The second one means like makes things harder because now like you can rerun the same query and like you won't necessarily get the same hash each time. So it just takes potentially more time. It doesn't mean like that doesn't that the friend doesn't fully get away. No, like for me like the idea of having like now the catalog managing some state, considering like we don't even have like a semantic layer and don't necessarily know like how things are interconnected. I'm not sure how that works. For me, like the only thing that like the second SHA protects against is really about like, oh, like I really want people to mask things and allow like joins in the context of a single query to keep working. But I'm really trying that like people to not be able to extract the data and try to run a separate query in a different system of things and try to see if things match. I think that's the only purpose of that random hash mechanism.
No, I totally agree with you, Laurent. What I'm trying to say is not to say that random SHA-256 is not going to be used. It's much more so that from a usage perspective, where you're really trying to make sure that your data is not
my point was more like let's try not to make the salt or like the random string something that the catalog send to the engines, because I think for me it's becoming very hard to manage, and like I don't see like practically like how it would happen. So
I totally agree with that. What I'm trying to say is like decouple the query one and then one where we still like have this world where people would want to maintain that global secret. I'm not vouching for that to be implemented. It's just that if we're actually trying
that's
to
something people could do using UDF in the future, and so if they really wanted to, like they could create their own hash functions which do like concatenations, and like if assuming they know so like how things are linked together. So
agreed. Can I ask one more question on this front? Then what are we achieving? Like, okay, we are saying that if catalog takes the responsibility of generating that salt, it can handle both the cases of having a query level hash. So essentially in the load table, you every time get a new salt, or having a global hash that, okay, this salt is consistent for you as a user. Whenever you as a user will be joining across or loading this table, you'll get the same hash back. So that could be one of the ways to achieve both the things rather than having query and global. But if we don't want to do that and let everything at an engine level, that is also something that is achievable but this will only achieve the engine level isolation or the query session level isolation for running this, in which every time you load the table, engine is supposed to generate a new hash and everything. So my other question is that, do you recommend in having that kind of a global salt, or do you say that, okay, this should not be advertised, or this should not exist? SHA-256 table should not exist as a global way to having that. I didn't understand the whole point that Sung was trying to make, like, completely. Sung, do you?
Yeah, sorry. I think a lot of different points were brought in, right? So what I'm trying to say is I think it helps to understand the policy intents separately. One is a query local one, which in which you're not interested in joining data across tables or across query sessions. And that already achieves some kind of user outcome where you don't really have to understand whether you don't have to encode into the Iceberg REST catalog whether two columns within two separate tables are the same, like semantically, right? Like as Laurent is saying. But from your human knowledge that these two should be the same, you can just use this action, use this mask to actually achieve that outcome. The other one, similar to SHA-256 stable, if you want to actually manage the semantic layer as an enterprise, you could potentially want to do that. I'm not vouching for that problem to be solved or for that action to be there, but I'm just saying that that is a policy intent that someone could have, right, for the secret to actually be passed in as a part of the action so that they can manage that semantic layer and consistently hash into the same value across tables and queries.
Lauren, do you want to go again?
Yes, I have a question. So, like, I'm confused. Like, do you actually want like a SHA which works only at the table level, but like you cannot join data across tables in the same query? Is that like what you're suggesting?
At the query level?
I mean, there's a query level. I mean, both at the query level, both basically works with joins. The first one is something like if you repeat the same query, you will get the same result. So it's stable in a way. But like it exposes you potentially, like if you extract the data, to potentially match with like over information. The second one, like a lot of joins, but like each query results are different.
Mhm.
And so it makes harder for you to, if you extract data, to match with like over data sets. Like I was confused about like what you were asking about, because you mentioned like not being like not allowing join. For me, it would mean like it would be like a third SHA would be like, oh, like the salt is basically like per table or like per like per scan. And in that scenario, yeah, you will not be able to join across things.
Right. So I think there is two different use cases here. One is to join within a query, and then one is to join across queries or across tables. And the mechanism with which you
Okay,
generate
so it
that-
was like across queries. Okay, so the
Yeah.
first table is across queries in a way, and the second one is like in a single query.
That's right. All I'm saying is the stable one doesn't allow you to inject that secret. If you wanted the additional layer of security, then you could. I'm not in any way vouching for that to be implemented, because Lauren, as you said, it is very complex to manage that as an enterprise, to manage that semantic layer. But I think thinking about these separately will help us come to the right conclusion when we're talking about the query local hash.
Sure, I think that makes sense. I mean, we can take it into more deeper level, but I think if we want to have like still maintain the posture of having a global hash, but that not being susceptible to the attacks that you're mentioning in short of 56, maybe UDF is the answer for that. But definitely, let's continue more on this discussion on how we conclude on that. But at least so far, this is the two things, and these are the two data types we have. And definitely, let's discuss more on the next thing on this one. We are already past 10 minutes, so sorry, I'm just trying to conclude. Appreciate your points, totally get it. Okay, so thank you everyone. I think I have next action items on some of the masks that we discussed, and we will continue discussing the short of 56 table and the random sort and seeing where we want to go from here. Okay, cool. Thank you. See you in the next sync. I'll update the meeting notes shortly. Bye.
Thank you.